Now let's focus on iptables implementation. iptables is the Internet Protocol software or user interface to net kernel which allows your Linux system to implement a fully featured firewall, which means stateful as well as stateless firewall. It operates primarily at layer 3 and 4 of the OSI model, and again allows you to filter traffic into and out of your system. Let's label this section iptables, and it's primarily a firewall for Linux. However, iptables is an interface to netfilter, which is loaded by the kernel during startup of the system. Because it's a firewall, it operates primarily at layers 3 and 4 of the OSI model. And by primarily, we mean for the most part, since a firewall can be configured to operate at various levels, including layer 2 when filtering based on MAC addresses, or layers higher than 4, such as 5 through 7, when using application-based plugins. iptables is modular, which means in and of itself it's loaded or called by the kernel as netfilter, as modules, and also supports advanced functionality such as proxying and access to layers higher than 4 using modules that you can download from the internet. So it's a full-featured firewall. In addition to all these features, iptables provides network address translation support. So it provides network address translation, or NAT, support, which means you can turn your Linux box into a router similar to a home-base Linksys or SMC or a D-Link or similar device, or even for an office such as a Cisco base or compatible or comparable router. So you can use one IP address connected to the internet and share it with all of your internal hosts. It provides forward and reverse NAT translation, which means outbound and inbound based NAT translation based on ports, distinct IP addresses, and so on. So iptables is fully featured. Again, it's an interface to netfilter, which means iptables is a user-spaced application or user-based application that we interact with to gain access to the firewall that's loaded by the kernel when the system starts. It is enabled by default, and one way you can check is to execute grep config netfilter from boot config for the version of the kernel that you're running. The config file that's located in boot contains all of the options that were enabled or disabled for the current build of the kernel. If we navigate to boot and ls, you'll see that the version of the config file is 261853 for this system. So if we grep config_netfilter from boot config 2618, etc., nothing's returned because it's represented in uppercase, as are all of the options. But if we case-insensitively search, you'll see different options that pertain to netfilter, with the most basic option, config_netfilter, set to yes. Let's update our documentation to reflect the case-insensitive search for netfilter options that are configured in the version of the kernel that's operating on our system. So again, config_netfilter equals y tells us that netfilter support is enabled with the current version of the kernel. Now there are different modules that are supported, including network address translation, classification, queuing, the ability for netfilter to log traffic that you instruct it to log, and many other such features that are indicated as modular for the most part, which means they can be loaded when the kernel loads netfilter by calling the appropriate module. Here we see a match MAC. This is access to layer 2 of the OSI model. It provides netfilter the ability to, or with the ability to filter traffic in and outbound based on layer 2 MAC addresses, which you can reveal on your system by executing ifconfig and by extracting the hardware address associated with the network interface that you'd like to filter on. So IP tables allows you to filter based on this layer 2 address. So by primarily, when we mentioned before, primarily layers 3 and 4, we should also note that you do have access to other layers. IP tables can also access other layers, i.e. 2 and 5 through 7, with modules, such as the connection match for the MAC address that is configured to be modular for this particular system. So we see match underscore MAC in our output, which is set to modular. So enough of the dry theory. We know that IP tables is supported because NetFilter was compiled with the kernel. Let's identify the primary RPM package. RPM query all grep I case insensitive as usual. IP tables. This will search the RPM database for IP tables and return any applicable packages, which includes the primary IP tables package for version 4 of the IP protocol and the secondary IP version 6 IP tables package. In the next section, we'll look at IP tables 6. In this section, we focus on IP tables version 4, since version 4 is the predominant protocol. RPM queryless IP tables reveals all of what's included with the IP tables package. It isn't too much, by the way. We see that in the init.d directory, there's an IP tables entry, which means IP tables can be started as a daemon, or initialize when the system is booted if rules are defined for IP tables. The default configuration that we've elected to set up on this system has no IP table rules in place, which you'll see momentarily when we execute IP tables with the -L option to examine the contents of the default table. That's the filter table. We do see beneath lib IP tables various modules, but before we get to the modules, there is a sysconfig entry located beneath etc, and in a separate shell. Let's just attempt to interact with the file. We can look at it as a non-root user. It contains options that are to be loaded by IP tables when it starts. Again, there's an initd entry, which means when the system boots, IP tables will start as a service. Here are any modules that are loaded. IP connection track with NetBIOS name session support, and if there are other modules that are to be loaded, you can indicate as such by space separating the desired modules. Whether or not modules are to be unloaded when the service is restarted, that's IP tables, or stopped. And by unloading the modules, we release some of the system's resources, namely memory. Whether or not IP tables is to save its configuration when it's stopped, it's set to no by default, but if set to yes, will cause IP tables to write the rules to this file. And that is the file we've interrogated, etc sysconfig IP tables. Whether or not to save current firewall rules on restart. Again, it's written to the same file if the value is set to yes. So there's a save on restart as well as save on stop directive. It's advised that you set both of these to yes in the event that you intend to use IP tables heavily on your system so that you don't run the risk of losing rules that may have taken you a considerable amount of time to write. Whether or not to save counters, depending on your environment and the requirements therein, you may need to determine, or you may need to save the counters associated to have it incremented whenever IP tables is restarted, so you have a full or aggregate view of traffic that passes through the various IP tables rules. If you're an ISP, for example, and IP tables guards some of your customer systems, perhaps, depending on interface, you may want to save the counters so that you have a total packet count, a means for quantifying traffic flowing through to and from a given client system. So setting the save counter to yes will ensure that whenever the system or IP tables is restarted, the counters will resume where it left off. So if IP tables, when stopped, for example, made it to, let's say, 600,000 packets, then when you resume, you'll be at 600,001 packets and onwards. And there are other directives that are defined in the file. So again, this file tells us, the iptables-config file that is, tells us the configuration information iptables is to read when it starts. If there's just a plain iptables file, it will contain the rules that iptables is to process when it starts or restarts. Again, nothing's saved, so it doesn't exist. But keep that in mind as you work with iptables, that you'll need to send the rules or save the rules into etc sysconfig iptables. Let's just note that. Save rules in etc sysconfig iptables so that when iptables is restarted, the rules will be applied. Or update etc sysconfig iptables-config to save the rules automatically. And we'll look at both momentarily. Now, returning to the output again, there are various modules that are included by default with the iptables package, including rules for classification of packages, destination NAT, connection marking, net maps, mirroring, masquerading. All of the features that iptables can provide, or most of the features we should say, are included via the modules. TCP support, UDP support, time to live, type of service, you name it. It's implemented by a module, and there are many other modules you can download online. The primary binary is located in SBIN, and it's called SBIN, or it's called iptables in SBIN. There are two other useful binaries that we can use to work with the access control lists. So this file is the primary ACL modifier utility, whereas restore restores the rules to the currently running instance of iptables, restores rules to current iptables instance, whereas iptables saves rules to stdout by default, or to a file if you use output redirections. After you've created your rules or your access control entries, which constitute your access control lists, you should save the rules to a file, a text file, preferably etc sysconfig iptables, or to some file that's accessible that you can use to restore the rules when you're ready to return or resume functionality. Now, with all that said, let's just discuss the tables, the default tables that you cannot delete that are included with iptables. iptables includes 3 default tables. As its name implies, iptables, it manages rules or access control entries in tables, and it ships with 3 tables that you cannot remove. So it includes 3 default tables which you cannot remove. They include the NAT table, where rules are stored for network address translation, the mangle table, where packet mangling takes place, any source NAT, destination NATs, or any sorts of mangling that need to occur will happen in the mangle table. The filter table, which is the default table, includes inbound and outbound rules. Filters inbound and outbound traffic. It includes inbound and outbound rules.